Now in this video we are going to discuss about standard scalar or standardization, another process of data transformation. We have already seen the normalization. The only difference between the normalization and standardization is the range of the value that will be transformed to. So in the case of normalization, we can have the value of range between 0 to 1. In the case of standardization, you can choose any range. And there is also a difference in formula that we use in the case of standardization and normalization. That is only the difference. But the performance might vary depending upon the situation, so it is better to know both of these techniques. So now in this video we are going to discuss about standardization by using standard scalar. Now this notebook explains how to use the standard scalar encoding technique from scikit-learn. So this is the library that we will be using. This scalar normalizes the data by subtracting the mean and dividing by the standard deviation. So if you recall the formula, then our formula tells us that for any standardization of the value x, and yes is here for standardization, you take the value that needs to be standardized, subtract with the mean and divide it by the standard deviation. Or we can also simply put here mu for the mean of a population, and sigma is a standard deviation for the population. We have already seen this formula, and this formula is for standardization. In the case of normalization, it is pretty simple. So we take the data, we subtract it with mean value, and we divide it with max and mean. So this was normalization. We already did normalization. It was pretty simple because only the calculation here needs to be done is to find maximum and minimum values. But in the case of standard scaling, you have to find mean, you have to find standard deviation. Although if you are using a library, then you need not find this. Algorithm will dodge it, because calculating these values for large data set won't be possible. So algorithm will find this mean and standard deviation, and then you will have the standard values for your data sets. So this is the formula. So basically this formula tells us that your data will be centered at mean, and mean will have a value of 0. It is kind of a Z distribution, or it is kind of a Gaussian distribution where your data follows this pattern, and here at the center you will have a mean, and the mean value will be 0. So this is a standard distribution. Now using this concept, we are going to discuss how to perform standardization of our data. So we have used the same module that we used in the case of normalization, the same library, but here instead of using min max scalar from this pre-processing, now we have used standard scalar. Only the difference is this: if you use min max scalar, then you will perform normalization. If you use standard scalar, you will perform standardization. So that is only the difference, standardization. Now using this library, we are going to perform standardization. So I have imported the data. This is the same flight data, which contains the information of arrival time, departure, flight information, and everything, the origin and destination. And now we are checking if there is null values onto our data frame, and yes, we found that there are quite a few null values, and here we handle them by dropping those null values. So drop NA will drop these null values, and then we also converted these values into something that is hour, minute, and so on. So this was the same that we did in the case of normalization, and we split our data into the target variable and the independent variable here. So independent variable will be used to predict the target variables, and after that we split our data into multiple training and testing sets. And now after that, this is the line of a code that will perform the standardization. Just take a look at this part of a code. This will be enough. So in order to perform the standardization, we created the object of standard scale. So this is the object that we'll be using. So if you remember, we use min max scalar for normalization. For standardization, we use standard scalar. And the function that we will call will be also exactly the same. If you just remember, in the case of normalization, it was the same fit transform function, and we give the values, that is input, that needs to be standardized. Now after standardization, we again get the data into numpy format. It will be in fact in the numpy arrays. So if you want our data into the previous format, which is pandas data frame, then we call this pandas data frame library and give the data that has been scaled. Now after scaling, you will find our data that has been completely changed into sort and scale. And this is how we do standard scaling. Now let us execute our code and let us check. So first of all, I'll just toggle all my output. Now let us execute this line of code, which will import all the libraries that we will need. Here in fact the most important library is this standard scalar libraries that takes the data that needs to be standardized and give the standard scale. Now let us execute this line of code. Sometimes this line of code does not work, and if it does not work, if it takes a lot of time and give you a timeout error, then please execute it twice or thrice maybe sometimes, because there are so many people that are calling these functions at a time and you might get an error. But now you can see that data has been imported. Now I can check if I have any null values. Then I found that the department time column, department delay and arrival time, these had all these null values. Now what I can do is I can drop those null values here. That is what I have done here. From the data frame, I call this drop NA function, which will drop all these NAs from each of these columns, and I'll run this. Now again, if I execute the same line of a code down here after dropping those NA values, then what I can see here is now no longer I have those null values. All of them are 0. So 0 here means they are counting how many null values are there, and it is printing 0 null values. Previously it has this null values here. Department time has in fact 8255 null values previously. Now none of them have null values because we just handled it right here. So there are other processes also to drop or to handle these NA values, but in our case I just dropped it. Now after see here, after we just drop it, maybe I can show you our data frame, maybe the head part of our data frame. So I will call data frame dot head, and this function will give us the top 5 rows of our data. See here, these are the top 5 rows, and here you can see arrival time, schedule time, and they are quite a numbers. So I don't want them into the numbers, rather I want to split them into hours and minute. So for that I take the arrival time, I use the apply function. It will take all these values one by one and convert it into the hours, minute, and I do it for second, these columns also. So the same things I did it right here. I also converted this into minute, hour, and so on. And now if I execute this line of a code, then we will see that now previously if you go here, this was all the data frame that we have. It contains arrival time, scheduled arrival time, but after executing this, now if again I check the head of my data frame, now multiple columns will be added for us, which are right here at the end, because if you remember, whenever we add any other column, it will be added at the end of our data frame. Here, see here, we created this arrival hour, which is right here. In the arrival hour, we added the hour of arrival. So this is 8 hours, and arrival is 30. So 8 hour 30 minute was the arrival, the expected arrival, and scheduled was 8:19. So 8 hour 19 minute was the scheduled one, and the actual one was 8 hour 30 minute. So you can see quite a delay here over here. So the expected or the actual, it should have been is a 8 hour 19 minute, but in actually we got it in the time frame of 8:30. So that is quite like 20, so 11 minutes delay in our flight, because our original was 8:19, but we reached there by 8:30, 8 hour 30 minutes. So now we also split our data same as previous. After that, this is the code that I'm interested in. So previously you can see right here our data is not that scaled. So that is not that scaled. These are not quite into the range. So I run it, and see here now if I execute this line of code, and I'll show you our data. So previously our data won't be into the format. See here, it is not into the format that we want. So these numbers are not within the same scale. Some are big, some are small. See here in this scheduled arrival time, see here some are 1022 and some are 830. So that means there is some difference within this scale of the values. Some are big, some are smaller. If you check all this data, then you will find a lot more than that. See here in the arrival minute, some of the flights have 4 hours and some of them have 50 hours. So there is a difference in our data. So we don't want to use this data as original data, but rather we need to transform it into something that will have a same standard scale, and that is what we have done right here. So having the same standard scale means having the scale that has the center at a mean and standard deviation of 1 unit. Now if I execute this line of code, then what I will find is now after executing this line of code, the standard scaler has been created. We would call the fit transform where the data is passed which needs to be scaled. Now if you execute this X train scaled, this is the data. If I execute it, then you can see this is returned as a numpy array. So whenever you call this scalar function, it will return us as a numpy array. Now it is very hard to read from the numpy array. What I want is I want the original pandas data frame, something like this. So that is the reason I take this numpy array, I insert it right here, because if you remember it is inside X train scaled. So I take that X train scaled and I created a pandas data frame so that I can read it carefully. Now if I execute it, then you can see all of them has been converted into the range between -1 to +1. So you can see this is the data, and this is for the training. We can also do for the testing now. So this is for the testing. Now if I just do the same things as I did for the training, then you can see now the testing has been also standardized. So in this way we can use only these 3 lines of a code to perform the standardization. We can call this standard scalar. This is the object where we have instantiated, and our object name is scalar, and from that scalar I can call fit transform function and give the input. Over here I have passed the values that should be standardized. In our case I want to standardize these values, X train yellow and Y train. I want these to be standardized, so I pass it here, and now I saw the standardized format, but I don't want them in a numpy array. Rather I want them in this pandas data frame so that I can get them into this row and column format. So that is the reason I created a data frame and passed this numpy array that I have just created as they are scaled, and I have just stored it into this row and column format. So this way we can perform a standardization. We have also seen a normalization in the previous video. These two concepts are very important, and we will be using this in our project while creating the models, and we will see how this kind of a concept will affect machine learning algorithm and how the accuracy can be increased by using these concepts of feature transformation.